Okay. We're on to problem 2. I should be wearing my hat. Probably work better with my hat and this. The kinetics of the following reaction is investigated. So I have the reaction being, and I'll put my head away, 2A. Gives me C. Okay. And there are 10 mLs of, was it 0.2 molar A, reaction with a total volume total volume of 50 mils. And it takes 100 seconds. So I want to find what is the rate of the reaction. Okay, we've got enough information. In this case, since I'm talking about it in terms of A, the rate, and this is going to be the average rate. It's an initial value problem, is equal to what in terms of A? Yeah. Why the minus 1/2?
Molarity?
Yeah, the stoichiometry. The stoichiometry. If it had been B, it would have been minus 1/3. And why the minus sign?
It's being consumed.
Yeah, because it's being consumed. And the rate has to be positive, otherwise you have reactions going backwards in time. And that would be very awkward. So, all we have to do then is find delta A, and delta A is delta A. The final concentration minus the initial concentration. Okay, what is the final concentration of A in this reaction? Equals 0.0 molar minus, and now I have to look at this. I have 0.2, so I'll write it as 2.0 times 10 to the minus 1 molar. And it's going to be times, how many liters do I have? 10 mils. How many liters is that?
What's that?
1.0, I'll just write 10 to the negative 2, 10 to the negative 2 liters. So it's moles per liter, I'll write that as moles per liter. And that gives me the moles of A, and now I have to take into account the total volume. Is that, should I, all right, let me rewrite that. That's, you can't read that from across the room. (2.0) times 10 to the minus 1 moles per liter, moles of A per liter. And there is 10 to the minus 2 liters of that, 10 milliliters. And what's the total volume?
50.
Over 5.0 times 10 to the 1, or 50 mils, which is 5.0 times 10 to the minus 2 liters, okay? And that's equal to minus, okay, now we've got to simply take care of this. Is going to be 2/5, but now I just got to deal with the exponents. What's 10 to the minus 1 times 10 to the minus 2?
10 to the minus 3.
Yeah, 10 to the minus 3. What's 10 to the minus 3 divided by 10 to the minus 2?
10 to the minus 1.
Just add, so it's 10 to the minus 1, 2/5 times 10 to the minus 1. 2/5. What is a fifth? 0.2. So 0.4. So it's equals minus 0.4 times 10 to the minus 1 moles per liter. Or that's equal to 4.0 times equals minus 4.0 times 10 to the minus 2 moles per liter. Okay? Better follow that part?
Would it be kind of simpler math just to make that 20 times 10 to the negative 2? But you can see your 4.
Yeah, that would probably be easier to see it that way.
Maybe.
Yeah. 20 times 10 to the negative 2 would work out perfectly. Does that make it easier to see?
Yeah.
Yeah. Yeah. This would be easier to do in your head if we made this 20 times 10 to the minus 2, then 20 divided by 5 is 4, and then the exponents take care of themselves. We've got 10 to the minus 2 times 10 to the minus 2. Well, 10 to the minus 2 divided by 10 to the minus 2, so we're stuck with this 10 to the minus 2. That works out much nicer.
Units or more?
I like that better, yeah. Moles per liter, 'cause this is moles per liter. The liters cancel on moles, so this is now moles per liter, so it's molar. Does that make sense? Yes, Jessica?
So, if, I thought that,
We're not done with the problem
oh,
yet.
no, I know. I thought that the concentration was just equal to the molarity, though.
No.
No?
No, in other words, let's talk what this states. I took 10 milliliters of 0.2 molar solution, and I put that in into a reaction mixture that had a total volume of 50 milliliters.
Okay.
So I have to calculate the actual molarity of the material that's present there. And so, yeah. And I like James's point. This would be much easier to handle. In fact, let's just redo it that way. This is equal to 20 times 10 to the minus 2 moles of A per liter times 10 to the minus 2 liters over 5.0 times 10 to the minus 2 liters. And that math is much easier to do. So I like that trick better. His was better than mine. I'm getting dingy, obviously. So this 20 divided by 5 is equal to, that's equal to 4. And the minus 2 divided by minus 2 cancels out. 10 to the minus 2 divided by 10 to the minus 2 cancels out. That's 1. And it's 4 times 10 to the minus 2. And then the units are moles per liter. Per liter equals 4 times 10 to the minus 2 moles. Okay, and but that was negative. Yeah. So that approach works better. I like for in terms of calculations. That would be a much better way of looking at it. So I have a problem like this very early on when your brains are fresh, long before you see anything like that thing we just did. And so having solved that, now we can simply plug that into the equation. And the rate is going to be equal to stuck with a board in a stationary place, so the rate equals minus 1/2, and I've got minus 4.0 times 10 to the minus 2 molar divided by 100 seconds.
Can you just say 10 to the 2?
10 to the 2 seconds?
Okay, yeah, so you can say it.
Yeah, by 100 seconds. And so then 4 divided by 2 is doable. The minus cancels. And 4 divided by 2 is 2. And so I end up with 2.0. And now I've got 10 to the minus 2 divided by 10 to the 2, which is what? And it'd be molar per second, or we could do it as 2.0 times 10 to the minus 4 moles per liter per second. Same.
Here in the key.
The
it's
keys
like
for
same-
the keys
yeah.
to the wrong one,
But
yeah.
it's the same problem.
Yeah,
2a plus 3b is c, and
Yeah.
you have like negative 1/3.
It's a different, he has different amounts.
yeah, that was a different,
But still, it's better.
it was the same reaction in the key. Let me find the key.
It's asking about B though, isn't it?
Yeah.
Is the question?
Let me find the key. Okay. Compelling reaction. That one I'm talking about B.
Oh, okay.
And B is the stoichiometric coefficient was 3, so we had to divide it by 1/3. Okay. Yeah. And my apologies for giving you the wrong. Gave you the right key, but for a different test.
That 1/2.
Problem 3 is the same.
That negative 1/2 is just products over reactant.
Okay.
Or what is that?
What?
How does the 2 drop down?
The 2. What do you mean? Where? Here?
Negative 1/2 is the stoichiometric coefficient.
Yeah, that was from the stoichiometric
Of A.
coefficient of A. Yeah.
And then it ends up on the bottom. For what reason?
Because for where we're after the rate of the reaction,
Yeah.
and there are 2 A's consumed for every one
I follow
process. So we have to divide the rate that the 2 disappears at twice the rate the reaction occurs. So there are 2 consumed, so I take the rate the 2 consumed and divide it in half, and that's the rate of the reaction itself. Make sense? Okay? And it's negative because it's being consumed.
There we go.
Okay, so is that all the questions with this one?
Yeah.
Okay. Stop the camera. And we'll go on to problem